Hello, thank you very much for joining us today. Water Pumping Institute wants to welcome you all to our webinar. Today we have with us Matt Angell and also John Williamson with Water Informatics. What we're going to talk about today is how to grow a $1 million crop with proper water, fertilizer, and energy use. But the optimization of controlling the pumps properly with technology that gives us the ability to see what's going on a real-time basis and reduce energy by proper utilization of the water, the pumps, the moisture content in the ground. I'd like to let Matt jump right in and basically give us an introduction of how he's going to be able to help you. And we appreciate everybody coming in today. Thank you.
So one of the things that we always see that's first and foremost is to map your soils. And it's ironic is that the USDA believed in that as well. Almost every acre in the United States has been mapped by the USDA. It's called the Soil Conservation Service when they first did it. But it basically is our bank. So the key here is to understand soil variability. And when I talk about soil variability, we look at this map and it's two-dimensional, meaning that we get to see exactly what's going on. If you look off to the left, I've got 3-foot soil cores that are sitting there. That makes that picture three-dimensional. So what we did is you can see that we've numbered each one of these sites. And what we did is after we ran this VIRUS or this electroconductivity map, we went out and we actually decided where we were going to pull cores. And then we actually pulled core samples. So you can see in this core sample, it's probably a little heavier loam up on top. We get a little layer right here about 6-8 inches down. It's sandy, goes back to a loam, probably down all the way to 1.5 feet. And then we get back into sand, and that's a pretty sandy soil right there at the last part of that soil core. So understanding first the variability two-dimensionally as we see on the screen right there on the map, but then taking it to the next level and understanding the core samples is really critical, because now you can see how that water moves through the soil. Understanding soil types and characteristics, I do like using there's 4 or 5 apps that you can use to map soils. I happen to use the NRCS Web Soil Survey. When I click into the variability of these maps and we look at them in detail, they'll print out a description of these soils. So in that blue area, that area is called the Tujunga sandy loam. The red area is a Hanford loam. So the actual permeability, infiltration rate, cation exchange, all the things that are really important about a soil are listed in that description. But what's most important is this soil infiltration rate. So how many inches when you irrigate does that water go down into the soil? So as an example, if you're looking at your active root zone, and let's say it's an almond, depending on the soil type and kind of irrigation you're using, that where that active root zone could be is, in my particular orchard, is at about 12 inches it starts and probably goes down to about 24. So there's a 12-inch active root zone. So the key is, how do I hit that target? And that's really important, when you start talking about soil moisture, and we'll get into that, how we map those things out. So again, we just pulled core samples and we looked at the variability of that block. Okay, now I can't move. Any ideas? Oh. This is a classic. So this is step number 2 for us, and it's funny because we can talk about measuring, we can talk about all the things we want, but understand that variability, that field's critical. But then the next, and maybe the most critical thing, is that in most irrigation blocks, what happens is it, let's just say that it's 20 or 40 acres, right? I think this is a 40-acre block split into 2 sets. But what you want is the distribution of the water to be at 90% in all 4 corners. You want the system to be highly efficient, so it delivers both water and fertilizer efficiently. So you can see there that I look for a 90+ irrigation or distribution uniformity. One of the things that you can do is that the NRCS has programs that you can actually get your system tested. Now that people use pressure compensated emitters, the uniformity's gone up, but that can be coupled with some problems in a pressure compensated system if your flows of your pump are decreased, or you run them at low pressures. What we see a lot of times with growers, if this is a 40-acre block and it's designed for 2 sets, what'll happen is they'll run it as one complete set, and then at the end of the day, uniformity of their irrigation is low just because of how they run it. So as an example, you've got variability of your crop. So that's really important to, that we pay close attention to DU. One of the things that, I spent 25 years designing irrigation systems. And what was funny is that everybody would just put in what they did in the other block or the other field or what their neighbor did. It's really important to pick the right emission device, the correct flow, the right spacing, and you try to match that emitter, that emission device to the soil infiltration rates and the soil variability. So what I did was, a lot of times is you'll see dual line drip, you'll see fan jets, spinners. Super important to understand your soils so you know exactly what kind of emission device you'd use. As an example, on the west side of our valley, if I use dual line drip in an almond crop, and I put those hoses on the outside or off to both sides of the tree, 2 to 3 feet off, what'll happen is that soil, as I wet that area, that soil pushes salt back to the center, and that causes some problems with the trees. Whereas if I used a fan jet and set it in the center of the tree row, it'll actually push the salts back out. So again, understanding your soils is critical. One thing that I talked about a little bit was to know the flow of your pump and verify it so it consistently matches your water needs, right? So here's what happens typically in most growing environments. Most people want to run their system off peak, which means from Friday at 6 and they go all the way to Monday at noon. That's a 66-hour run. Back in the old days, our water table used to be able to sustain those type of run times. But as from 12 to current in the last 10 years, due to the decline in our water table, our wells have become less efficient. So what happens is you'll turn that pump on, and if you're getting 600 gallons to start, in 12 hours, it might go down to 550. In 12 and 24 hours, we may see it go down to 500. In a 48-hour run, it may go to 450. So the point I'm trying to make is that as you pump that water table, if it's declining, some do, some don't, it'll actually affect the efficiency of that pump, which is something that Rob will talk about and why we are on the Pumping Institute. But as it affects that efficiency of that pump, it produces less water. And now the distribution of your system goes down. So we've noticed one of the things that you can do as a tool is that if you turn that pump on and you are going to use it, in that off-peak time that PG&E has allowed people to do from Friday to Monday, what happens is that if you'll write down your GPMs when you start the pump, go out there the next morning, see what your GPMs are, and go out on Sunday night and see what it is. And you can start to see if there's any variability. If there is, that will affect your DU. So again, I get back to, one of the things that I've got on this screen, and I happen to, after being in the irrigation business for 25 years, I spent a few years out of that industry. I sold my company, and then I ended up back in the pump business, and I own a pump company and a well drilling company now. It's Moderator Pumps. And so one of the things that we always used to get when we were designing the irrigation system was a pump test. Pump test is based on motor to wire efficiency, and so that pump test is a good tool to show you what the cost of your pumping requirements are, but your well efficiency is completely different. So you can see that red line, and again, it's just what I talked about, that cone of depression over a period of time. As you run that pump longer, you'll have that pump will decline in its pumping water level. It'll fall out of spec or out of its design. And then as it does, it will lower in flow. So that's something that just we need to be really careful of. Understanding the irrigation dynamics, it's the classic curve and the things that we always see here, but continuous soil moisture status is critical. Knowing where your active root zone, like we talked about, what that depth is, infiltration rate, how do I leach salts, what's my daily water consumption. It's an important one, the date, time, length of irrigation. One of the things that we've seen here in Madera in the last 3 to 4 years, again, because it costs less money to pump off peak, what will happen is people will turn all their pumps on, and I'm talking in a 20 by 20 area, and depending where it is regionally in the county or in your geologic location, what will happen is it affects the pumps of every pump in that area. So what we see happen is that off-peak time, everybody will turn their pumps on, and you'll start to see that water decline in that period of time. So a lot of times, if you understand when you're irrigating, how long you're irrigating, and what's going on, it's really, really important. And I've got here pesticide applications and disease infestations are reduced. One of the things that I didn't talk about, there's 3 things that a crop needs. One is, I used to say sunlight, right? But actually, hydroponics will teach us that all it needs is light, it needs water, and then everybody will say, well, it needs soil or fertilizer. Really, what crops, the third critical or necessary element for a crop is oxygen. So what happens in these run long time, when you run this system, again, over these long periods, if your soil doesn't have high infiltration rate, if it's not a sandier soil, but it's a heavier soil like a clay soil, you'll start to saturate that soil. That plant will stop respirating. And when it does, it drives the disease pressure. In that map I showed, in the very beginning, in that red zone, that used to be one block. That block used to sit right out behind my dad's house, and he wanted us to put that first probe in the weakest soil because he wanted to make sure that that's where we irrigated and kept that green. What was problematic about it is that we were irrigating that weaker area, and our good soil that was higher yielding and produced more crop, we were actually over irrigating and probably creating powdery mildew and different disease pressures in that area. So it's really, really critical to, again, to understand those soils, not saturate them, and know the emission device that you're using. Again, as I said, critical target. I had to chuckle a little bit because as you look off, over here to the right, you see this wisp of grass. Hopefully nobody thinks I'm getting into the weeds because of that. But again, we talk about this effective root zone uptake. This is typically the 70%, and this is just this looks like Milo or something, but it's a good example of where our consumptive use in a plant is and where we actually need to target. 70% of that active root zone is really critical for what we understand. And when we start talking about soil moisture, the first question I usually ask people is, how much moisture you got down at 2 feet? If the answer is I don't know, then that's a question that you absolutely need to understand. You need to understand where that water's moving, how you're irrigating, that kind of thing. So top half of the actual rooting depth supplies 70% of the crop's needs. That talks about, transpiration, evaporation, and then, this last line, capillary rise and deep percolation. Again, in a sandy soil, that wetted area will be narrow and long. So wherever that dripper's dripping in a sand soil, you can do any kind of experiment you want, but the best experiment is go to the beach. As the wave comes up on the shore and the water disappears, you know that there's no water holding capacity within that soil. That's exactly what happens in a sandy soil, on in a block. So if you're dripping in that spot and the next dripper's 36 inches away or wherever it's located, you may not be getting a good wetting front or a good wetting pattern. So it's really important, again, to understand the dynamics of your soil. I love this slide, and the reason I do is because one of the things that I talked about was how I used to have to probe and what I did, for my dad. And I thought I was doing a good job, but we'd see yields in our vineyards that would go from 8 tons, and then some years we'd get 12, and then it'd be 7 the next. Once we started putting these soil moisture sensors, and we were actively pursuing, that target root zone, one of the things that happened is that we were able to have a predictable outcome of our crop. If there's one thing that a farmer needs, is predictability. And it's really, really important that if you can recreate success year in, year out, your ability to be sustainable is really important, is paramount. So we went from yields that we saw these varying ebb and flow yields from high to low to consistently knocking out, 13 to 15 tons in that same crop that we would vary from 7 to 12. That's how important this was. So you can see, as you look at the phenological stages of that crop from bloom, leaf, nut, growth, nut maturing to recovery and set, those are really important things. Ironically, after we get done farming, we're usually pretty tired. The years beat us up. We traditionally think that it's going to rain, and we kind of put that off. One thing that we've noticed is that, we're farming permanent crops, right? There needs to be moisture there. So the rule of thumb that we use is keep 60% soil moisture in that soil all the time, even when it's winter time. And the reason we do is that, again, it's a live plant. We know that if we keep that cambium, hydrated, it's probably going to be more effective when we get some chill hours. That we won't probably have to press on it as hard the next spring, but that is critical. When we start looking at recovery and set, we need to be really understanding what goes on. So this is a full year process. You can see off to the right there that, we talk about gravitational water. That's saturation. When you start looking at the soil particle or particles. Field capacity. Field capacity means that that soil's filled and it's drained and it's at that perfect level. And then again, you can see permanent wilt, which is not something that we ever want to see in any crop. So this gives you a pretty good idea what goes on. What you'll note in this picture is that above ground is the canopy and below ground is the root system. If you look proportionately, we would see that it's 50-50. Ironically, though, we only get to see everything above ground, right? So being able to look down in the soil and understand what's going on is so critical. Because again, that's where our efficiency occurs. That's where our crops, our yields come from. That's where, that during, when we go into hull split and we go into a regulated deficit, it's really important to understand that your bank's still filled. All those things are critical because next year's crop's sitting in that tree right now. So it's really important. So the things that we look at when we measure, and you can see this, it says continuous real-time measurement. And I love real time. I love to be able to see after I've irrigated at night. I'll look at what's going on in my crops. I'll walk through them. I'll feel the leaves. I'll understand exactly where I'm at all the time, and that is critical for us. It's critical for being successful at farming in general because again, it's that predictable performance. So irrigation timing and strategy, target soil moisture, target fertilizer movement. One thing we know is when we put nitrogen into our drip lines, that nitrogen moves as fast as the water through the soil. So it's super important. Let's do an example. If I've got an infiltration rate, which means how fast that water moves through the soil, and let's just say in sandy ground, it's 2 inches per hour, and my active root zone's at 12 inches, and I run 66 hours, you can see that I've basically put water down to about 132 inches, right? That system ought to be run in that 2-inch infiltration rate soil, that sandy soil. If my active root zone's at 12, I probably ought to run it between 6 to 8 hours, turn the system off, and then come back and do it, the next day. Again, PG&E incentivizes us to run low cost energy. Super important because sometimes that weekend just allows us to catch up on the time that we don't, and that's really what we've got pushed up against lately, is that we just don't have enough time in a week to get across these fields. So it's really important to understand that irrigation strategy, but targeting your fertilizer and where that movement in is critical. So talk about environmental and weather. One of the things is that we see, when you irrigate for a long time in a heavier soil, what will happen when you've got a full canopy, like in almonds, you'll have a full canopy of the tree will be shading the ground, and the temperature in July will run up to 100, 105. If you're irrigating and you're on a little heavier ground and you've shut the oxygen off because you've saturated your soil because you've run a little too long, what'll happen is that you'll drive humidity back up into the canopy. And again, that's where we see the disease pressure, lower limb dieback, all those things start happening. 95%, any UC publication or any biologist will tell you that 95% of our problems in permanence or even crop production are due to over irrigation. If you're irrigating properly and you're using that, your good irrigation strategy, hopefully your energy use, can be minimized. There's guys talking about, I've seen guys that are, that are competitors to us and different people They're talking about growing, almond trees, and it's always interesting. I've always said that water and yield go hand in hand. There's guys talking about 3,000 to 3,500 pound yields using 30 inches of water. Traditionally, we've looked at 48 inches, just depending on what your soil is. But at the end of the day, that's what we're trying to drive is, that reduced time of irrigation. Our ability to look at pump flows and filter pressure is super important. Right now, we're seeing, as spring startup occurs, we're seeing filters plug. As those filters plug, specifically in a sand media, we're starting to see silt loads go into these sand medias. And what will happen is that the sand media will flush based on a differential pressure. When that happens and it keeps flushing, let's just say that filter flushes every hour. You're talking about on a 3 tank, and that's a small filtration system, 3 tanks. Each tank does about 250 gallons per minute. So when you flush it for 3 minutes, it's 750 gallons, right? 750 gallons times 3 tanks puts you at about what, 2,300 gallons every hour. So if you called out for a 10-hour irrigation due to ET and your filters are flushing every hour, and you think that you're putting 10 hours on, you may be only putting 9 hours on. So understanding and seeing that data come back to you on what those filters are doing, how often they flush, is super critical on how we run our irrigation systems. So here I am. This is kind of the old school thing. And, you can see me there in the top left. That probe's 6 foot long. The orange is on the bottom is the actual auger. I've got a 1 foot break, then it goes to 3 foot in that orange, 4 and 5 at the top. The next picture you see over to the far right top, you can see I'm down at 5 foot. That hole took me about 45 minutes to drill, and I've got really good soil to probe into. But how many times do you think I do that in a year in 10 blocks? I'm just not going to get it done. So in that picture off to the left, right where that probe is, that orange auger, you can see 2 white stakes. Right there in between those 2 white stakes is what we call a full profile capacitance probe. It goes 5 feet in the ground. And again, it reads 96 times a day and tells me exactly what's going on in that plant. You can see that we're about 3 foot off that tree. We're probably 3 foot to the south of it. And we try to put those sensors just about in the drip line. The reason those 2 white stakes are there, they're 2 steel stakes, is because when we run our sweepers through, we just want to make sure that they don't get damaged. But this is old school in how you do soil moisture. It's the hand fill method, right? We've all seen the books on how that works. In that bottom right-hand corner, you can see where I'm using my thumb to basically, do the fill method, see how much water there is in there. As you press it, it forms a ribbon. The longer the ribbon, the higher the moisture. I always like to look at the color of my fingers when I'm in a different field. Heavier clay soils will make my hands dark, black. Sandy soils, you'll have no color. So observation is critical. Then off to the bottom right, you'll see that little, looks like a worm, but actually it's a 1/4 inch root. So that was about 2.5 feet down. And I know that's a feeder root for that tree. Really important to identify. The challenges you have with soil moisture is that when you take a sample, when is it in the irrigation cycle? Did you just irrigate? Was it 3 days ago? Was it a week ago? When did you last irrigate? And if you don't understand when you irrigated in relationship to when you pull that sample, it could be skewed. Highly labor intensive, difficult to track and plot over time. It's hard to predict when an irrigation occurred, and then it's difficult to target fertilizer applications. Again, the irony of this conversation is that when I when I first started doing this and I had to probe these fields by hand, I was looking for anything. So actually, I built the original system just for myself. And then my neighbor started showing up and saying, hey, what are you doing? And I said, well, I'm grabbing this data, I'm piping it out to the cloud. We didn't even know that there was such a thing as a cloud. And I'm getting this data back. We were still using Windows 3.1. My dad was 78 years old, never used a computer before. And I got him to use a computer because he loved to see exactly what he did when he irrigated. So these are different soil types. You can see, these are the classic. You see aerometers. The one's a gyprock, that has the coiled wire. You see the other one, it's a, John, that's a tensiometer. Yeah, that's a tensiometer. You can see the, the gauge there. What you do is that's a liquid filled. It shows tension in a plant, and that is a critical measurement. The problem with that sensor there is that it measures one spot in the profile, right? And you can look at Decagon. Again, they've got these one point sensors. And then you look off to the far right and you see full profile sensors. The sensor on the left is a newer type. The old one off to the right is the classic old sensor. You can see the top of it. It's an SDI 12 board. That was the interface for gathering that data. But it's interesting to look at that probe because you can see the high and low bands, that the gold there. And that's, how the soil reads. It basically sends a loop through those two sensors, those two brass plates. And that's how it looks at the speed as it goes through the soil to tell you how much soil moisture you have. What's interesting about, that full profile is that it's really important that when you set those probes that you put it in one place and it's sealed and healed, right? That there's no, what we called was preferential pathway, right? So with the Decagon device, if you're going to put one device at 12 foot or 12 inches, one device at 24, one device at 36, super important that you pack in the soil so that mimics the rest of the soil, and that when you irrigate, that water doesn't find that hole or that preferential pathway, and then you get a false reading. Syntec came up with a system that basically we bored a hole through the plastic casing, pounded the casing in, and then slipped that old school capacitance probe in, and they really worked really well. I'll get to the next slide and I'll show you kind of what that looks like. So you can see there again, that's a full profile probe. The top one's doing the first foot, the second sensor's doing the second foot, third, fourth, and fifth, obviously, right? Now, the top picture is a T that you would see that typically hooks up to your riser that brings water from the manifold, from the filter, from the well, right? That T, we put a transducer on, and that allows you to see exactly when those irrigations occur and for how long. So you can see the arrow on that top chart showing how long that irrigation happened and what, and the length of it. And then you can see above it, this top line that we've got here is the sum of all 5 charts. So in that case, you look up at the top and you can see, well, we filled it because we had a long irrigation run. Went for a while, we bumped it. You can see off to the right up there, you can see the bump in the irrigation, a little longer bump. One of the things that we've done in Informatics is that we automate systems as well, but we'll put a transducer out at the valve, and that gives us a snapshot on the system uniformity. So when you turn that system on, you can see that valve pressured up. We put it downstream of the, typically it's a Bermud valve and a hydraulic valve. And what happens is that when you put that pressure switch downstream of it, you can see exactly the pressure and how much water went into the, how much pressure there is in the system. Super important, because at the end of the day, you'll want 15 to 20 pounds. And if that sensor doesn't, if that transducer doesn't tool up completely, or it doesn't show the pressure, you've got a break in the line, something's going on, the pump's not pumping enough. So those are really important things. So we like the idea that we can actually set an alert on that transducer that says, hey, you're in low pressure, you probably ought to go out to the field and have a look. Again, you can see, we've put windows on this. You can see as that bump in the as that transducer or that irrigation system turned on, you can see, and it's ironic, in the first window you can see that it was a short set and it only affected the first and second foot. The third, fourth, and fifth foot, it just kind of didn't really do anything. Again, we had another irrigation after that. We bumped it a little longer, and then we shortened the time span to the next one, ran a little longer. And now down at the third foot, we finally got, we've bumped the soil moisture there. One of the things that I always emphasize to my boy, and this is a really tough year, super important that, because we are trying to fill our water bank, because what happens to us typically is that as these trees leaf out, that those trees accelerate. They'll start using water faster than you can put into the system. And what it'll do is it'll dry out that bank. And after it does, up about wherever that level is, but that transition from maybe loam to sand, you'll get an inversion or a bicarbonate layer there that seals off. And for the rest of the year, you'll have water sitting on the surface, and you'll never be able to get that water back down in the soil, or down into that lower bank. So right now is really important to kind of be pushing now that we're leafing out, but you got to be really careful that you don't put too much water on, because we got May winds coming up. And if you've over irrigated, now we're talking about trees falling down, from wind blow. And, it's a delicate balance. Again, it's so critical to understand exactly where your soil moisture is for a plant. This is kind of talking about the same things. We see that, for field capacity, and you can see, just as an example, field capacity that, in that sum chart up on top, off to the right, you can see where we put 2 long irrigations on. It went up, it dropped down, and where it kind of levels out is actually where field capacity is. That's where you want to set your high line. And then that red line below is, let's drop down. Oh, there's no lines on this chart. Let me look at the next one. But you can see the as we filled, and then you can see also down on the 48-inch, those 2 irrigations that we did on August 28th and 27th finally hit our bottom 48-inch sensor and finally bumped it and brought it up. That bottom sensor is a perfect example of field capacity. It jumped up, came down, and then leveled off. So this is a perfect example, of what we're trying to talk about. We've got the ARZ sum, which means the active root zone. You can see the green line at the top, the red line at the bottom. And what we really do is we just tell people, look, drive between the lines, irrigate as you need to. And you can see that this grower had a host of irrigations, depending on their soil type, what their phenological stage is of their soil. Are they blooming? Is the plant leaving out? Are we in nut fill? Are we in maturation? Are we going into regulated deficit? All those things matter, when you're growing. And again, here's, plan, schedule, and establish benchmarks. We love to do that. Again, during that winter dormancy, it's important to refill your bank because there are no leaves. It's important to keep that that tree hydrated, that cambium hydrated. You get into bloom, root flush, nut fill, hull split, harvest, post-harvest, and senescence. It starts all over again. Nutrient, as I say, nutrition and irrigation staged strategically. Again, our tool set basically allows you to look at, when you should be putting nitrogen, phosphorus, and potassium in. Obviously, boron and zinc are less mobile in a soil, meaning they don't move much, but nitrogen, it'll gas through the soil. So it's super important to understand the strategy that you use and how long you use, or how long you turn that irrigation system on. So next year's crop starts with today's irrigation strategy. So we're looking at how do we solve problems: water efficiency, irrigating in balance with crop and water requirements, targeting the active root zone, time it to the growth stage, and then look at real-time DU. Our ability to understand the distribution uniformity of a field is critical. Well and pump efficiency, it's important to know the GPM requirement of your irrigation system to maintain a high DU. And the other thing is as you pump on these wells and you run those long well sets, there's 2 or 3 things that go on. One is that as you draw down in that well over time, sometimes you'll open up the perforations to air. You'll get more biofouling. But the other thing is that well draws down from your standing water level down to pumping water level. Over time, what happens is the speed of that water going into the perforations, because that pump's pumping at a very rapid pace, as that water comes through that perforation, it basically breaks down, and there's a bicarbonate that forms on that perforation. It'll actually seal your perforations. That will seal your well over time. We've seen carbonate layers in wells that can be up to a half to a full inch thick, and it's really difficult to open those up. The other thing is that these wells will biofoul. If you're pulling too hard on them, they'll break, because the difference between standing and pumping water level, there's just a differential in pressure. So the top part of the well and where the well seal was, it'll actually cause that well to snap, and then you have to go in and fix that. So that's really important to be able to see down in that well, literally down in the well with a transducer, and see in our system, we'll actually set warning levels and critical levels. At critical level, will send you a text and say, hey, better shut that pump off or you're going to have some problems. Targeted and timed fertilizer, match growth rate to rated development, higher efficacy in nutrients and less leaching. Again, the environmental concerns, you got this 3D soil dynamics versus 2D. Let me pull this up. Bicarbonate soil oxygen ratio, bicarbonate layers with high TDS, leaching. And here's the big one, and the one that we're really working on hard right now is that daily ET fluctuation. We think, as time goes along, that we'll actually be able to understand, these soils and through our process and through soil moisture, be able to target an exact irrigation for that crop requirement, whether it be daily or every other day or whatever that looks like. So one of the things that I always talk about, is to respond in real time. So, what are the field conditions? We're solving problems that we can't visually quantify, right? It's a statement that we make all the time. We don't know what we don't know. So declining groundwater, I don't know. I'm a pump guy. I go into wells, 4 or 5 times a day with videos, but I always ask the question, is this the weekend? Is this the actual standing water? So we don't get to see it unless we've got a device down there measuring it. System flows and pressures in the field and at the filters, that's critical. control irrigation for soil water strategy. Obviously, we talked about reducing disease and pest, optimized energy, maximized yield, nutrient dense products. You know, we can up our game. There's no question by how we do things. And the last one that, you know, that I find pretty interesting is that, you know, the system, the platform that we use will allow us over a period of time, in conjunction with our ability to calculate daily ET. And I'm not talking about using a Davis weather station. I'm talking about using, you know, a sophisticated heat sink, you know, heat energy flux system, basically a satellite. And we're seeing them everywhere. We're seeing them down south in semi-tropic. There's a group, I'm not sure what they're called, but the group we use is Irrigation. Irrigation is actually able to tie into our soil moisture probes. It looks at how long we irrigated today. As that satellite flies over, it can tell us exactly how much time we should be irrigating tomorrow. So the idea of machine learning, people were just, you know, really concerned 5-10 years ago when we first started doing soil moisture. You know, we don't want to automate. Now we're seeing, due to labor, precision irrigation are requirements, knowing that we have to run an irrigation set during the night. You know, all those things are critical for us, but most important, as this system learns exactly what goes on in that crop and where our targets are, we can refine our irrigation strategy, I think, to the ability where the system can at least help us decide on what we're going to do on how we're going to irrigate. One of the things that I, you know, as a company, I always get pushback from my partners, but you know, there's an ROI for us, and soil moisture ROI is like 3 months. Super simple to return on investment. Anytime you can have a return on investment that's less than a year, I think is critical. But one thing that we do for sure is that we guarantee success. If we can't do what we talk about, then at the end of the day, we just give your money back. And I think that's the kind of people that you need to do business with. Again, one of the things that I love looking at is, you know, is this is a, you know, Google Finance, and this is on Potash Corp, and you can see that price increase and then drop. I always tell people, if you got $40,000 in the market, you might look at your stocks, you know, every week. You got 100,000, you might look at them every other day. But if you got $1 million investment out there, the likelihood of you watching it and you wanting to set an alert's pretty high. And the way I see that is everyone, you know, every 40 acres that we've got either in land value or crop value, this land and what we do is highly, it's got a high cost to it. So in real time, it's super important that we track our investment. I'm going to let my partner, John Williamson, take over. John's our software development guru, and he's been involved and been my partner, my business partner for 20 years, and, you know, and watched what we've done. One of the things that we believe in is that, you know, we build this stuff for farmers. So, John, okay.
Yeah.
Matt has covered such a lot of ground, and I think he's done a great job. And so I'd just like to take a few minutes just to talk a little bit more about how our product actually how it works and addressing some of these issues. It'll be a really short presentation. I want to make sure we leave some time for questions. So I'm going to just click through and talk in terms of our product is called Water Informatics. And really, we learned a while ago that really to be able to meet the needs of farmers, you needed a very flexible and open solution that could meet many different needs. So we actually specialize, we focus on going out and finding the best tools that are already used in industrial automation and other industries, and figuring out how to adapt them to the agriculture environment. What it leaves us with is a very flexible platform that can be used for many different purposes. I think the last count, we're up to about 30 different modules that are available. I'm not going to talk about all 30 right now, but our point is that we're really able to use an integrated platform to come in and focus on both pump and irrigation efficiency issues, helping growers really understanding where they can save money, both on labor and other inputs, and then most importantly, looking at impacting crop health and overall production results with a tool that gives you predictability. So we've built a very solid foundation. We've got hundreds, if not thousands, of sites out there already. We've been, as Matt and I have been at this for about 20 years, and this product we've had in use now for a good 3 or 4 years. So you've seen some of the examples of the soil moisture. This is a screenshot that I just took this morning. It's live data in that sense. It just shows you where some farmers are at already. For example, a month ago, a 10-hour set was sufficient to refill a profile completely all the way to 48 inches. A 12-hour set today is only making it down as far as 16 inches. And so it's really critical to have this information. You can see root activity here all the way down to 48 inches already. This soil profile is drying out fast already, and we're still in March. Another example of is looking at year-round health of a crop. When you learn to drive between the lines and you ensure good plant available water at every growth stage, you see the results right away in every growth stage in terms of improved health, and it significantly reduces the risks of farming. So soil moisture is really our foundation offering. However, and it includes all of the reporting you might need in terms of irrigation activity, we really like to give farmers a full history of what's been going on in their ranch so that they can feed that into their decision making. Beyond that, we're also putting out sensors that are monitoring more than just soil moisture. So this is an example where there's a lot going on this page, but I just wanted to draw your attention to the blue information in the middle. We're monitoring pressure across a ranch. Here we've got some very healthy pressure numbers, and that's a good indication that you've got distribution uniformity. It doesn't replace doing a full uniformity check, but it does confirm that if you've got good uniformity, that you're able to maintain that, sufficient pressure to ensure distribution throughout your system. You can be sure that all the plants are getting an equal amount of water. This information can be viewed not only on a desktop environment, but everything is replicated on a mobile environment as well. So you can carry with you all of the information on your phone. We also have spent a long time figuring out how to reliably monitor flow meters. Increasingly, that's a big need for growers, and not just for reporting requirements, but actually really to also make sure that the pumps are working efficiently and really keeping track of exactly how much has been delivered into the field. This is a simple example of a flow meter application, and it's kind of a hard road to travel, really capturing remote flow meter data, but we feel like we've really tackled it and got a good handle on it. We also moved into the pump monitoring and control area a while ago, and you can very easily today using our system, you can start and stop a pump remotely, and you can do that straight on your phone. You can set a schedule for how long you want it to run, and so this takes us in the whole area. The pump control area takes us all the way into, we're really bringing industrial automation into the farm, and it's been really well received, super reliable. It just works, and this is really the system, the platform we provide is as good as any other pump control system in the world. It's one of the most widely used platforms. 15,000 industrial organizations around the world using this platform. It's rock solid. At the same time, we've made it highly affordable for farmers. This gives you a little peek into some of the wide range of different tasks we can handle, but it's just straightforward filter monitoring, flow meter monitoring. Also, we do well monitoring. We do hook into VFDs and track all the critical outputs from a VFD, including the ability to adjust set points remotely and change the speed on VFDs remotely. We also had a lot of inquiries about monitoring incoming line voltage, where people are not happy with their utility. And so we've done quite a lot of voltage monitoring projects as well. It's really built in a modular format where we can just plug in whatever solution a grower needs. This is an example of a well level monitoring site. This is a graph showing the well adjusting. You can see that towards the end of the growing season last year, the water level was, this particular well was really struggling. There was even one time where the moisture level went all the way down to the critical water level. And we tracked that. Obviously, it's not always easy to find alternative water supplies. But the good news is that we were able to monitor throughout the winter the recovery. This particular graph, you can see all the pumping events down at the bottom, and then as the pumping events slowed down, you see the water recovery, and we're seeing as much as 70 or 80 feet of recovery on this well over the winter. So super critical information to understand the health of the well. This I think maybe the last slide is really just a quick glimpse into the automation system we have. We have a full featured irrigation automation solution that can be, you can schedule irrigations directly from your phone, or you can set up complex multi-day, multi-week schedules. It's really an industry-leading scheduling tool, and it's an area where we're really shone in terms of being able to deliver full feature irrigation scheduling in the agriculture environment. So it's been a fun ride so far, and we're looking forward to reaching out to many other growers in the future to help them with their specific needs. We have a broad client base already, and obviously looking to get our message out to other people. This is our contact information if anybody wants to follow up with us directly. But we're here. We're going to be putting on more education events. I know Matt's got some other ideas already about programs he wants to run. So maybe you'd like to talk about that for a minute.
Yeah, I want to keep it short, and I'm sorry if we went a little over, but one of the things that we're looking at is that right now it's really important for us to be monitoring wells, filters. We're just seeing a lot of issues going on, and obviously our ability to automate, has been driving a lot of interest in a lot of farmers. So if there's anything that we can do, we're excited that you guys were able to take your time out of your busy schedule and hang out with us. If there's any questions, I'd be happy to take them. As John has our email up here, we're happy. Those are our cell numbers. You can write those down. You can call them. We pick up the phone. So whatever we can do.
Thanks.